everyone, welcome. My name is Barb Moses. I'm the CEO and co-founder of Monte Carlo. We're a data reliability company. I'm really looking forward to speaking today about data downtime, introducing the concept, explaining why you should care about it, and how using software engineering best practices can help manage it. Really looking forward to seeing you all soon. Let's get started. So as I mentioned, at Monte Carlo, we're a data reliability company. We help enterprises trust their data by minimizing data downtime. Previously, I was a vice president at Gainsight, which is a customer data platform. I'm also a math and stats lover from before. And I'm a huge Bruce Willis fan. That's probably the most important fun fact about myself. Love Bruce Willis movies. And in particular, if you've seen some of his, if you've seen Die Hard 3, actually, there's a great math problem that Bruce Willis solves. And so I think Bruce Willis is also a data guy, actually. Maybe we'll get his thoughts on data downtime one day. So let's jump right into it. What is data downtime? So as I mentioned, I want to talk a little bit today about the rise of data downtime. I'll explain what it is. I'll talk a little bit about data observability and how that applies to data downtime. And then I hope that you'll sort of leave this talk with kind of a few practical tips that you all can take and implement in your data lake tomorrow, if you'd like. So actually, to explain the concept of data downtime, let me start by telling you a story. So if you're at this conference, you probably embody one of these personas or are familiar with them. In every company, there's someone like Rebecca, works a lot with Excel and spreadsheets, perhaps driving insights that are important to the marketing team in particular. Perhaps you are more familiar or see yourself in analyst Anna, who's sort of the SQL queen and works closely with data analysts and potentially even your financial folks to help them build reports and make decisions based on those. And potentially you see yourself in engineer Emerson, working mostly with Snowflake or BigQuery, probably has some data scientist or ML background. And potentially you see yourself in manager Michelle, who uses kind of reports in Tableau or Looker to make decisions every day based on data. Now, what's common to all of these people? Well, all of us actually experience data downtime in some shape, way, or form. And I'll tell you a little bit about my personal experience with data downtime. I'll take you back to 2016. I was at Gainsight, and we started using data way more heavily as an organization. And I was responsible for the team that was generating this data and was actually using reports to make these decisions that were sort of used by our board and our executives. And it felt like every Monday morning I would come to the office and there would be this like plethora of sort of issues with the data. There was this report that was out of date and that number that seemed a little wonky. It just felt like a whack-a-mole game of figuring out why the data was wrong and where. And here's the hardest part about it. It was actually not us, not the data team who was finding out about these issues. It was our downstream consumers that identified those problems. Sometimes it was my CEO, sometimes it was actually our customers. Regardless, it just felt like the more data-driven we were trying to become as an organization, the harder it was to really trust the data. And we were sort of plagued by a lot of these issues. And the irony was that the more we were trying to use data, the actually harder it became to trust it. And so pulling back from my personal experience, I really sort of identified in the industry, this is sort of something that, most teams actually experience. For us in particular, obviously, this sort of translated into time that we were wasting on figuring out what the problem was instead of actually building things that could have helped the business. And in other organizations that I work with and speak with, oftentimes having bad data translates into actually material revenue that's lost. So I spoke with actually an algo trading company a few weeks ago, and they described a particular instance where there was a schema change which resulted in bad data, which actually cost them $10 million per week because of that sort of change in particular. For some companies, whether you're in financial industry or healthcare, or even more broadly, potentially even in retail, where having bad data might result in material compliance risks. Say, for example, if you're missing credit card data in particular. Those are kind of specific examples. A third one here for how data downtime or sort of bad data can impact your company is obviously the erosion of trust, right? For me in particular, if I can't trust the data, why would our consumers trust our data, right? I was just talking to this e-commerce company not too long ago, and they told me something very powerful. They said, data really is our product and data is our business. And when the data on our website is down, it's actually as bad or even worse as our website being down. So as you can tell, sort of the problem of kind of bad data or data downtime, it's a very serious problem that really kind of impacts across industries and across data teams. It's really hard to avoid it. So maybe kind of the good news here, or maybe the comforting news, is that we're not alone, right? As I mentioned, sort of no industry is spared. There's sort of a widespread problem and affects companies across industries. It even affects the government. In fact, it was published earlier this year that the US government accidentally sent $1.4 billion in COVID-19 stimulus checks to dead people. You know what the culprit was in this case? It was actually a table that was out of date. So a very serious matter that really impacts everyone. When we actually think about sort of actually the meaning of data downtime, what the definition of it is, let me introduce to you kind of the proper definition. Periods of time when your data is partial, erroneous, missing, or otherwise inaccurate. Now, where does the word come from, right? Let me draw a corollary here to application downtime. So I'll take you again, probably a couple decades ago, to a time when people were just starting kind of building applications and just starting having things like a website, for example. And when a company's website was down, actually nobody cared. Nobody cared because nobody was using your website, nobody knew about it, and very likely no one was really responsible for it, right? In those days, when your app or website was down, it wasn't a big deal. But today, that's really unheard of, right? There's this whole kind of industry and set of tools of solutions that emerge to help us manage application downtime or APM market. I think the same thing is happening to data. Today, sometimes in some pockets or some areas, we can have our data being wrong and maybe it'll be overlooked or maybe people won't notice and maybe that's okay. But a few years from today, 5 years from today, I don't think we're going to be able to get away with that. I don't think we're going to be able to get away with sort of data that's wrong or reports that are inaccurate or out of date. It's costing us too much and it's slowing us down. And so as a corollary to that, I think data downtime is one of the things that as an industry, we really need to rally around, start measuring and improving so that we can manage it in the same way that we've managed and made huge strides in application downtime. And I think by giving it a name, data downtime, it'll help us better understand how to manage it and also sort of treat it with the diligence that it truly demands. So you might think, okay, fine. So data downtime exists. This has been in existence, and everyone is sort of familiar with it. But why should I actually care about this, right? Well, here's why. The reason you should care about data downtime is because, in fact, it is costing you millions of dollars, especially if you are not doing anything about it, and it's actually getting worse. So here's sort of a few examples, kind of a framework to think through what does data downtime actually mean for me? Why should I care about it? Just specifically, if you think about the labor cost, if you think about the number of people on your team today, the number of engineers who actually spend their time on data fire drills. Do you know that number, right? Do you know sort of what kind of the percentage of time that they're spending on these issues, and then what does that cost? So we found that a data team on average spends at least 30% of their time on data downtime. And if you actually multiply that by the annual salary of an engineer and the number of engineers who are dedicated to sort of your data platform, that should give you a good sense of the real labor cost that you have for data downtime. The second is sort of the compliance risk. And so we talked a little bit about companies who sort of track or sort of use data in their operations, and by having bad data actually puts them at real risk of compliance. So just to use it as an example here, for GDPR, the fines are 4% of your revenue. And so in this case, you could calculate it as 4% of your revenue in a previous year. And then finally, and maybe one of the most important costs is actually the opportunity costs. These are all of the things that you could be doing while you were not working on a fire drill with your data. So all of the revenue that you could have generated if your team could free up to build that new product, to enter that new market, to acquire this number of new customers. This is sort of real revenue that you could have been generating if data downtime would have been mitigated. Actually, if you tile these up, you kind of get the kind of annual cost of data downtime. I actually spoke to a data team not too long ago that sort of reached out to me and was asking, hey, how should we think about data downtime? We're trying to build in-house, but really struggling with sort of building something for kind of a solution to manage data downtime. And I got really curious about it, and I was asking, hey, like, how come you don't have time to sort of deal with this, sort of manage data downtime? What's keeping you busy? And the thing that was keeping them busy was actually the data downtime and the fire drills. And so as organizations, data teams today are actually very reactive and spend a lot of time in data downtime, when in fact they could proactively solve data downtime, get ahead of these, and reduce the cost. And so I think as organizations think about truly sort of leveraging their data lakes and their data infrastructure and truly becoming data-driven as organizations, it's important to think about what is the role of data downtime in our organization? How often do we have data downtime, and what's the real cost of it for us? Now, once you sort of thought about kind of the role of data downtime in your organization and how you want to address it, one of the most powerful ways that I've found to address data downtime is by leveraging ideas and leveraging methodologies that actually our counterparts in software engineering have been using for years. It's pretty awesome that we don't have to reinvent the wheel. Actually, I would argue that in data we have a lot to catch up on. And the cool thing is that this is why we have software, right? There is software to solve exactly these kind of problems. And so I'll talk a little bit about how can we use concept from data, how can we use concepts from observability and apply them to data in a way that will help us address sort of the real imminent threat of data downtime. So starting a little bit by talking actually about DevOps and observability. So for folks who are not familiar with this concept, engineers often leverage sort of principles of what they'd call site reliability and observability to ensure that their applications are performing as expected, and that application uptime is high while downtime is low. Now, why did this even start, right? Why do you need observability to begin with? Well, as organizations grew, as software engineering sort of increased in its importance, and the underlying tech stacks that are powering them become way more complicated. For example, as folks move from a monolith to microservice architecture, as a result of those changes, it's become incredibly important for DevOps teams to maintain a constant pulse on the health of their systems. And so observability kind of speaks to this need and refers specifically to monitoring, tracking, and triaging of incidents to prevent this data downtime from happening from the get-go. And so as a result of this industry-wide shift to distributed systems, observability engineering has emerged as a very fast-growing discipline in the last couple of decades. Now, at its core, observability engineering is broken into sort of three pillars, as you can see here on the slide: metrics, traces, and logs. Now, metrics sort of refer to kind of a numeric representation of data that folks measure over time. Logs are a record of a specific event that took place at a specific timestamp as well, and can give the context regarding kind of the specific event and when it occurred and why. And then traces sort of represent these kind of causally related events in this distributed environment. Now, these are all concepts that are very, very well known in software engineering. And honestly, if you think about it, every engineering team that respects itself has some way to measure observability, right? Potentially something like New Relic or PagerDuty that DevOps teams use to manage and optimize and reduce downtime of their applications. Now, the question that I would like to pose today is, if every engineering team has something like this to manage their applications and the health of their applications and the uptime of the applications, why are we flying blind in data? Why don't we have the same thing in data? I actually think that is sort of where kind of our journey begins for data observability. So what is data observability? How do we define that? Data observability is an organization's ability to fully understand the health of the data in their system, thereby eliminating data downtime. And so again, this kind of draws on the best practices of DevOps observability and bringing them to data pipelines. And so similarly, like in DevOps, we can actually use automated monitoring and triaging to identify and evaluate the quality of the data itself and kind of address observability and discoverability issues. Now, the goal of data observability is to creating this lens or this consistent view into the health of your data itself, not into the infrastructure, but rather the data that is flowing through the pipelines, and understanding proactively when things are sort of going down. This actually leads to more reliable data, healthier pipelines, and ultimately more productive teams that can move faster, that can make better decisions, and better decision making and stronger companies. And so we're talking about kind of the data lakes and the future of data lakes today, but how do you actually make this a reality? So let's walk through a couple of examples for what does data observability look like in practice. So again, drawing sort of a little bit on the corollary here for observability, if you think about applications, they can break for a million different reasons, right? It's a complex system. Numerous root causes can happen, but there's an agreed upon set of metrics that folks track, measure, and optimize in sort of the world of DevOps observability. However, in data, we haven't defined those yet. We don't know what those metrics are that are needed in order to create this observability. And so we actually created, took kind of a crack at what you'd call data observability pillars. And I believe is that these pillars together bring sort of the power of observability to data and can help you sort of reach that same level of rigor that we have in DevOps. So these 5 pillars, I'll walk shortly through each of these. So freshness really sort of speaks to how up to date is the data. If you're sort of expecting a table to get updated 5 times in an hour and it's not being updated today, obviously sort of the data is not fresh, and you want to know about that in real time. The second pillar is distribution. Distribution really refers to, at the field level, at the column level, what is sort of the range of the specific values that you expect to get? What do you actually, what is sort of the null rate for that particular data set? And what is sort of the distribution of the data? And is that in line with what you expect, given sort of the history and given sort of maybe the seasonality and a few other factors that impact your company? The third pillar is volume. So, thinking about kind of row count and byte size and different ways to really think about, is the volume of data consistent with what I expect? And the fourth is schema. So schema is really kind of any sort of change or kind of difference in sort of the organization of your data. Maybe a table that was added or removed, a field that changed from an integer to string, basically kind of different audit checks to make sure that you are aware of schema changes. And then finally, lineage, which sort of helps bring all of this together. And lineage sort of includes both metadata about assets, but also sort of an automated way to help bring the story together so that you can say, okay, somewhere here upstream in my data lake, I have a freshness problem. And this is related to this distribution problem downstream, which is now impacting these reports, which are being used by our CEO to make important decisions. So lineage can help us sort of tell the story of all of this and help us understand the relationship between these data downtime incidents, as well as the impact downstream and upstream, the root cause of them. And so, I think when sort of for folks thinking about data catalogs and data governance, these sort of an automated way to think about these data observability pillars is a very powerful sort of first step to think about that. So let's actually, walk through some real examples of like what data observability looks like in practice. So here's an example which, I assume sort of is feels very familiar to folks in the audience. If this was, if they were sort of live, I'd ask folks to kind of raise their hands if this has ever happened to them. So let me ask you, has it ever happened to you that someone in your organization sort of changed a field somewhere upstream, which resulted in, a change that impacted a downstream table or report, kind of resulting in missing or partial data somewhere? I assume this would have happened to kind of anyone or most folks in the audience. A very common problem, right? And a very sort of strong example of data downtime. Actually, when you have data observability methodologies in place, there are ways to avoid problems like these to begin with. So for example, what you can see here is actually sort of this map of all the dependencies of a specific field or table or data asset. And when you have this automatically generated map, you can actually make changes to a field way faster and with way more confidence because you know who would be impacted downstream, and you can avoid that damage to begin with. And so we actually find that when data teams have this sort of data lineage or data observability in place, it allows them to move faster. They spend way less time recovering from downstream impact that they may have caused accidentally, and have way more sort of confidence in moving faster. So let's look at another example. A very common example is when a specific dashboard hasn't been updated in 24 hours, and potentially, you didn't set a specific, kind of threshold or test for that dashboard, and potentially that dashboard has been updated, but maybe an upstream source hasn't been updated, and so maybe there's something upstream that's feeding that report that you're not aware of yet that has a delay. And in that case, oftentimes the person who's responsible for the data arriving on time and the person who is actually responsible for consuming that data are not the same person. And so there's this miscommunication. Potentially, the person that's using the report isn't even aware the report hasn't been updated or that the upstream source hasn't been updated. Now, when you have data observability methodology in place, you can actually have things like a machine learning based detection of these freshness issues. So think about sort of fully automated, scalable coverage of all of your tables, all of your data assets, so that you get alerted in almost real time, basically, as soon as a specific asset isn't being updated. And when you have that power in your hand, sort of that communication between folks on, is this data trusted? Can I actually use it? When was it last updated? Becomes way easier, and you sort of minimize these incidents where you're actually not aware of these delays to begin with. The last example that I'll talk through here, by the way, these are just a couple. The list really goes on, and I'd love to hear some of kind of your the best tales of bad data during the Q&A and maybe offline. But just to walk through kind of another example here, we talked a little bit about the miscommunication. Oftentimes, when there's a data downtime problem, there are many people who are involved in it. It could be the engineer, the data engineer, the product analyst, the data scientist, all of the personas that we talked about earlier experienced and are involved in data downtime. And oftentimes, the miscommunication is also a tool that takes sort of has a big impact on data teams. There's a lot of sort of back and forth in terms of who's actually responsible for this problem, who's owning the fix. Is it engineering? Is it someone else? The other funny thing about, or not funny, the sad thing about data downtime is that the longer the problem lingers, the longer it takes to fix. And so imagine if you had the power of observability, you could actually know as soon as the issue was detected, and you could also know at that same time what was the root cause. And so you could quickly identify who's the right person who's responsible for this, and who's the right person to own the fix and to backfill the data very quickly if needed. And so this sort of rapid triage and troubleshooting really allows you to spend way less time on data downtime and way more time doing sort of the revenue generating activities that you probably want to work on. So with sort of data observability in place and sort of starting to think about kind of data downtime and how to manage that, there's actually a great question that came up from one of our customers, which asked me, like, this is awesome, I'm tracking data downtime, but what's sort of a good, what's the right metric to track this, or what's like a good OKR, right? What are some of the ways where we can start thinking about measuring this, and how do we set SLAs and SLOs for data? If you think about sort of observability, they have like 5 nines and rates and errors and measure duration and all that stuff. How do we bring that to data as well? And so a very simple place to start out with, which is pretty straightforward, is by looking at kind of 3 key metrics, which I think are the most important one. The first is the number of data downtime incidents. So literally, how often do we have those? Is it a couple times a day, a couple times a week, a couple times a month? How often do we have these incidents, and are we improving on those over time? The other 2 metrics, so the second is time to detection. So oftentimes we hear from teams that it takes them months to identify data downtime problems when sort of the problem has many downstream implications. And the question is, can you measure how you're improving on that? Imagine that we could know about these problems within minutes, right? How remarkable of a progress would that be? And then the third measure is time to resolution. So, once sort of the issue is detected, how quickly are we at actually identifying the root cause, fixing it, and resolving it? And if you sort of think about this kind of formula, this together kind of starts to give you a sense of what data downtime is and how to measure it. And hopefully sort of a good starting point for you all to sort of shine in your organization as you kind of reduce the rate of data downtime overall. So there's one thing in practice. Another thing in practice that I find interesting that I think we can really adopt in the space of data from software engineering is kind of really driving home the point of automation. I think, I hear a lot from folks, kind of best practices that were very common maybe 5-10 years ago around sort of manual validation of data. So for example, something that's very common and I personally use as well is that before sending any important report for sort of decision-making purposes, we would always have kind of 4 or 6 sets of eyes to vet a specific report. We'd always have like someone like making sure that the numbers look right. And honestly, I think that could work fine a few years ago, maybe 5 years ago, but not today. It's kind of crazy to me that we're still working this way in 2020. I think we need to lean into data, into automation of a lot of these processes. And you can see on the slide why. I think the reason why is because it's taking us an enormous amount of time. We looked at how long does it actually take a data team to sort of manage these issues and to deal with it. And it ranges between, 27% of even a salesperson's time to all the way to 80% of data practitioners' time. And as I mentioned earlier, software engineering is at its core, meant to help automate a lot of these things. And I really believe in the power of that to help liberate data teams from spending so much time on sort of manual bad data validation. So to wrap up, just go through a couple key takeaways. I think if there's one thing that we can all agree on is that we're all getting more data-driven, not less, right? And for that really sort of requires sort of the solving the problem of data downtime. I think we, for some reason have sort of accepted it as life, right? Like, yeah, whenever you're dealing with data, there's some bad data involved with it. There's some data downtime involved. I actually think we can't continue to doing that way, right? I think we have to really consider that data downtime, in my opinion, is the biggest challenge that our industry is facing these days. The good news is that we don't have to reinvent the wheel. By applying best practices of software engineering, we can actually resolve this. And I think the first place to do so is with data observability, which can really sort of help alleviate this pain for our ecosystem. And I'll leave you sort of with this parting thought that sort of is really kind of inspiring to me. If you sort of think about kind of the last 5 years or the last decades of progress that we've made in the data lake ecosystem overall, is that in the past, companies really use data just to report, potentially report to the street once a quarter or something like that. In that world, we had a fairly large group of people that was responsible for probably a small set of reports and data, and using that only sort of once in a while. And in those cases, it was totally fine to have a manual process that takes a lot of time and allows sort of people to make really smart decisions based on their judgment calls based on data, right? And that made a lot of sense in that world. But I think in today's world and in the future, we are going to have, or we already having, large groups of people who are looking at large amounts of reports all the time. And if you look at companies like Uber and Netflix, where that is becoming more and more of a reality, people are using data to make decisions every day. I'll take that a step further. We're having machines making automated decisions based on data for us, right? And so here's the catch, though. If we want to get to that place where, we're sort of truly data-driven and truly sort of use our data in a smart way, I think we need to get the fundamentals right. And I know this sounds counterintuitive. We sort of have this natural desire, to sort of rush forward. But I have to believe that we need to nail sort of the basics, the accuracy, the integrity, the observability, the data uptime, so that we can enable this trust and confidence and sort of liberate both ourselves and our companies to actually have confidence in data on a large scale. The good news is that there's a path forward. And so thank you so much for the time today. Really excited to hear more offline about your personal data downtime stories and data observability methodologies. So looking forward to seeing you in the Q&A.